All right. Hello and welcome, everyone. Thanks for joining us today. I'm super excited for this talk. It's been a long time in the making. So I am Carolyn. I'm CEO here at Nextmv, and today I'm joined by Tiffany, who's our head of product. We're going to dive into the entire world of testing and experimentation today. We'll cover a quick intro of the Nextmv platform for anybody that is new to us, and then Tiff is going to dive into a demo, a quick speed run before kind of zooming out to look at the modeling and testing framework as a whole. And then we'll get into kind of the vast universe that is, decision model testing specifically for optimization algorithms. We'll do our best to save some time from some Q&A at the end, but please don't hesitate to kind of drop in some questions into the chat as we move along. We'll try to work those in, and this is pretty informal, so don't be shy. All right. So let's dive in first to what is Nextmv Platform. We are a decision automation platform. So the way to think about that is we help companies build, test, and deploy and operate different decision models. Those models might be doing things like routing for a distribution service or workforce scheduling for a retail company. And we've gone over various parts of our platform before in some of these tech talks prior. So things like our CLI and our SDK kind of help us with the workflow around that building and testing and deploying, and also modeling of these different types of problems. But today we're really going to focus a lot on our UI. So that is what we call our console. And we'll walk through kind of how you interact and collaborate on decision optimization throughout your company. So I'm going to ask Tip maybe a few questions as we go along here. So Tip, can you walk us through kind of how is testing typically done today? And what does it look like?
Yeah, definitely. So there's kind of two main paths that folks take. The first one is honestly the most common. Often you just don't have the time or resources to test. So you just have to ship it and hope for the best. And sometimes it bites you. This is an example where it's broken for 3 years and you just didn't realize it. So on the other hand, if you decide you really need to do testing, you're willing to climb that hill, you're faced with a really hard project. Testing tooling is hard to build, it's hard to maintain. And what we hear from our customers is it's not really the main focus of your business most of the time. Carolyn, I'd be interested to hear your experience with this.
Yeah, definitely. So when I actually just kind of got into the startup ecosystem at Zoomer, I was working with our CTO, Ryan, and they kind of hired me on as like a systems analyst and like simulation analyst for Zoomer. And so before that, before I kind of came in and started kind of doing these massive tests around like our dispatch algorithm, we kind of just shipped things. So when we were working on routing and scheduling and trying to make that really efficient for Zoomer, which was doing meal delivery kind of before Uber Eats existed. The kind of the testing paradigm was like throw it out there. Maybe throw it out there in a city. Small city, maybe a small town in New Jersey or something like that, and kind of scale it from there. And it was very much like the GIF you see, like, ship it, and then, oh my God, the ship like went ashore and broke in half, and you kind of had to, sit beside a dispatcher and make sure things were working the whole time. So can be super, super stressful. And even, after we started working with the simulation, like we still kind of had this scenario where we were maintaining the tooling and also the algorithm at the same time. So it kind of was complicated to keep that moving.
That's nerve-wracking.
Yeah, a little bit nerve-wracking. So can you give us kind of obviously there's a lot of things packed in there. So maybe can you summarize kind of why testing is particularly relevant in this space around, decision optimization? Yeah,
for sure. And this is really why I think we care about testing at Nextmv. So one of the big things is the stakes are super expensive. These are often low margin decisions. We have a really low tolerance for error. And troubleshooting without testing is really complicated. These are plans that drive real world activities. There's real people involved, and anything that people are involved in is inherently complex. And so it's really hard to have confidence in your outcomes if you don't have testing in place.
Definitely. So obviously, none of these are desirable outcomes, especially, if I'm here speaking as a now business stakeholder. Can you talk to me about some like real world examples? We always talk about internally making things super obvious.
Yeah, for sure. So we think about optimization primarily in these three realms, so routing, scheduling, and allocation. There are many different use cases within each of those, and there are many different stakeholders involved. They all care about different aspects of this decision problem. So as an example, if you're a decision scientist or an operations researcher, you care probably most about the changes to the model, maybe changes to a given constraint, versus if you're a product manager, you're caring about changes to the operations. Are there stops going unassigned? Are we meeting driver happiness goals? Things like that.
Yeah, that makes sense. In my experience, when we were at Grubhub, we thought about, testing how different, customer SLAs, right, would impact like our dispatch algorithm, or even maybe like evaluating where Slack was in our system. Like, so, if we were to make driver acceptance, more efficient, like how would that actually impact like our KPIs? So that's super interesting. I know you thought about this from like a completely different angle, working with the CDC during the pandemic. So can you maybe dive into like an example that's outside the supply chain space?
Yeah, for sure. So my work there during the COVID pandemic was really, I would say 99% testing. We were comparing multiple models to really help public health officials on the ground do things like schedule lockdowns and answer questions like how do we allocate a limited supply of vaccines in order to minimize spread. And you literally get one shot, no pun intended, at these decisions. So testing is super important there.
Yeah, that makes sense. And it seems like, just in general, testing is like a very collaborative, activity in this space. So, it kind of makes sense, like where, you see kind of these things be applicable across a bunch of different teams within an organization, or a bunch of different teams care, right?
Yeah.
And like, it also seems like there's like different layers of questions here. So maybe walk us through the different, types of testing out there.
Yeah, for sure. So yeah, there's a big universe of testing out there. There are some of these test types that you might be familiar with. In my own work in public health, we did a lot of scenario testing. That was kind of the primarily tool we would reach for, because you're looking at it over many different sets of inputs and configurations. Yeah, curious if any of these resonate with you. I imagine you've had experience with a lot of them.
Yeah, all of them at different times, right? I think, particularly at Lockheed, we were working a lot on like things like scenario testing, and even maybe a level higher than that with simulation. So yeah, these definitely resonate on that front. We definitely, as I said before, like, talk about making things obvious. To kind of bring it back to that again, can you walk us through a specific examples today, or a specific example of this, so we can kind of wrap our heads around what this means in practice?
Yeah, for sure. So at Nextmv internally, when we need to make something real, we often talk about it in the terms of the Nextmv farm. And so sharing a bit of our secret sauce here. But we'll use our favorite farm share example to dive in a little deeper about what we mean with testing and kind of how we're enabling it with the platform. So we have a farm share company. We've got a fleet of 5 vans. They pick up farm share boxes and deliver them to customer homes. There's some pretty simple constraints in here. Drivers have shifts. If they go over that shift, we pay them overtime. Vans have capacity. There's precedence. So anything you'd expect in a kind of a pickup and delivery problem, I would say. And so we have a routing app that's been developed, and it's running in production. And our team is testing out a new version in staging. So the perspective that we're going to dive into for this speed run is we're product managers at this farm share company. And we're getting some feedback from our operators that drivers are working overtime. And so our team has been working to create a new model, add some new constraints to address this on the ground problem that we're observing. So let's hop over to Nextmv and take a look at it. All right, zoom in there so we can all see. Cool. So now we are in the Nextmv console. This is our user interface where everyone from the team can come in, interact, see what's happening. Here we're starting out on our apps page. So these are models that have been developed locally, maybe tested locally, hopefully tested locally, and published to the Nextmv cloud. So now they're running remotely. We've got our farm share delivery model, which I just mentioned kind of the setup for, but we've also got some other models that are in development that we're testing for our Nextmv farm. So we can do things like schedule our workers and assign different tasks to those workers. So this is one place to go kind of for all the different problems that you're solving around decision automation.
Got it. So
And
these actually
so,
would be
yeah,
controlling different aspects of like the real world ops here. Like these
yeah,
plans would be
exactly.
like fed into like a driver app or, fed into kind
Yep,
of downstream systems.
yep. Yeah, and as you said, so if we go into this farm share delivery app, this is actually run in production, and so it's essentially acts as a microservice in your stack. So you've got this unique endpoint for your delivery app, and so it sits between kind of the data you get when you get your orders coming in, and then the plans that go out to the drivers. So this makes it a really kind of easy service to use in the middle of your stack. And so we take a look. So I mentioned we have an app running in production. So we have our production and our staging space. So if we take a peek in production, we see that that's our V1 app. We've already cycled through V0 and now we're on V1 and we're pretty happy with it. But we've got one in staging to address that operations constraint I mentioned, where we're seeing drivers go in overtime. And so our team added a new constraint to the model to consider service times so we can get some more realistic routes. And so before we dive into these model changes, let's just take a quick look. So this thing is running in production. And as the PM on the project, if I want to see like, what are these routes looking like? Are they decent? Are they realistic? I can take any of the runs. We'll take one that's running in production right now and just get a visual on like, what do these plans look like? Where are my vans going? Seems pretty reasonable. The farms are kind of on the outskirts of town. And then all the deliveries are on the city center hub. So it gives you a quick way of just diving into what's going on, even if you're not involved in the local model development, which is pretty cool. We go back into our app here. So we've got our production and staging instances. We're going to dive into our two different versions. And our team actually already set up an experiment. So we can just take a look at a kind of initial glance at how these two apps are comparing. So we've got our version 1 that's in production, and we're going to compare it to staging. So let's take a look at the experiment. They've already run it, so it completed, which is great. And so this is the summary for a batch experiment on the Nextmv platform. It gives you a quick way to dive into the metrics you care about your model. So the first one, that's kind of universal no matter what model you're working on, is value. So this is really how the solver is helping to direct to the best solution. In our model for delivery times, this is trying to minimize route duration. We care about not having routes that are too long. And so if we take a quick look here, so our production model's on top, our staging is on the bottom. Something looks pretty fishy. So these values are huge. That can't just be route duration time alone. I'm guessing it's related to a penalty value because we have some pretty steep penalties for things like unassigned stops. So from here, we can dive in and see what's happening. And again, you can look at any way you slice it, these values are really different. So something must be happening with this model and staging.
Yeah, something looks fishy, right?
Yeah. So we go down. So these are some of the KPIs that we really care about for this delivery problem. So let's look at unassigned stops because that's what we think is happening here. If we look at the production model, there were no unassigned stops. Now, if we look at the one with this service time included, we've got several unassigned stops for some of our input files. So there's definitely a problem here. So we've got those unassigned stops. We can see the distribution over the different size input files. And so one more thing to check is to see maybe we're hitting up against some limit of our just fleet. And that looks like exactly what's happening here. So we're utilizing all 5 vans, especially in that new model, but even sometimes in our model in production. So as a PM on this project, I would probably ask, like, this doesn't seem great to ship. I wouldn't want to ship it right away, but I'd want to test some other hypotheses. Probably the most obvious one is, what does it look like if we add more vans to our fleet? So we could test that right away without kind of going and asking for resources to do that just yet. So it's a really nice way to experiment without even having to go back into the code.
And do you work with like the decision science team on basically setting up some of these, I see custom in front of that. So like setting up some of these custom metrics directly in the app itself?
Yeah, exactly. So when they're developing the decision model, they include these as something that we care about in it explicitly. So you can have any number of custom metrics that you want. And then these are just the ones that we chose for this problem.
Gotcha.
So if we want to test our hypothesis, like what happens if we have a larger fleet, we're going to need an input set with more vehicles in our fleet. So the cool thing here is you can have as many input sets as you want. We've just got a couple, and it means that you're testing on the same set as your team member who's also running experiments. So for this one, we want to take one with more vehicles, and we want to look at it across a range of order volumes. So we have input sets that reflect low days and high days, which is good to get a range of what's actually going to happen in reality.
Makes sense. Yeah, I think at Lockheed we had like different ways to look at that when we were doing kind of like ballistic missile testing. It was like run the same like threat set, or run a variety, and I kind of viewed that as like maybe a compliance versus like a design set, almost similar to like stress testing your system.
Yeah, exactly. So let's go ahead and create that experiment and see what it looks like if we use more vehicles in our fleet. So we can start that experiment right from the console. We also have a CLI experience parallel to this, but it's nice to not have the context switch. So let's give it a name. We're going to compare large fleet, compare V1 to V2 using more vans. And so we're going to select that input set that we know has more vans to run this test. And we want to test the production instance against staging. So that's our V1 and V2 models. So we just kick off this experiment. It's running remotely. So it'll tell you when it started and when it's finished. So right now it started. Let's give it a little refresh. Let's see. All right, sweet. So that experiment has run. And now we can dive right back in. So we have those same set of values because we didn't change the model. We just changed the input set that we're running this experiment on. And we can see now we have our prod on top and staging on the bottom. So that value, the minimum route duration is much more in line with what we'd expect. So we expect maybe a little more time to be showing up, and we see that in some cases, but not astronomically more. So these are more in line, which makes us feel better about this model now. And then if we jump down to see if our unassigned problem has been solved, we see in all cases, we now have enough vehicles to cover the stops. So we're not getting any unassigned stops. And then now we need to see is how many vehicles do we actually need? And is this going to be viable for the business to increase the fleet to that size? So we see here across the range of what we think are realistic order volumes, we're needing like a maximum of 7 vehicles in this new case. So what's cool about this is you can then take this summary, share a direct link with your team, and have a conversation about, are we comfortable increasing our fleet in this case? Or would we rather pay overtime to our existing drivers? So it's a really nice basis for those kinds of business and operational questions.
And really trade-off discussions, right? Because like these systems you're not able to just kind of get a free lunch with a lot of these optimization systems, right? So it gives you kind of a context of like, okay, what am I trading, right? For maybe better delivery unit cost, something like that. Very cool.
Yeah. And you're having a conversation on the same kind of views every time. So it really standardizes that like format for you, which I've found in the past to be really helpful for those conversations. You're not constantly context switching.
Yeah, that was the huge thing actually for us at Lockheed. Like we made sure like any naval captain could kind of walk into a room that was like a new program and kind of understand what was going on, because we had the same set of charts, right? The same kind of flow through all of our design reviews. So that makes sense.
All right, let's jump back over.
Yeah, maybe we can just summarize really quickly. I definitely think if I was a PM on this project, like it would be super helpful to have all this, right? We had 2 models like running remotely, right? So we were able to actually like work alongside like our sprint cadence, right? So, look at production and staging at the same time, investigate kind of results. So, what I was saying before, maybe, dive in, look at some of those trade studies, and even like be able to create a new experiment. So if we had a new set of input files, something like that, you can test the hypothesis. And I think it's like easy as a PM, right, to think about like I can go in and add a couple drivers right to my input file and then go rerun it. That's a lot more tangible than maybe kind of building and doing a lot of that testing locally as a product manager. So that makes sense. Very cool. Awesome.
Yeah, for sure. And as I said before, like this really gives you something that's easy to share and communicate with across the team, no matter the kind of technical level that you're starting from.
Definitely. So now that we went through the speed run for like one specific type, right? That was very much like a batch test. Can
Yep.
we loop back to that testing page that you had before and kind of see how this fits in with the other types of testing?
Yeah, for sure. So yeah, as you said, what we just ran through was what we call a batch test. So we ran it remotely. We compared two models on several different inputs, a batch of input, if you will. That's partly where the name comes from. And so at Nextmv, we're trying to give shape to this universe. So we started to think about testing in the following way. Um, so grouping them in these buckets, so things like shadow testing and switchback testing go together. They're both happening in the real-time space versus debugging and unit testing that's happening locally. So what we ended up doing is putting together a framework for testing. So starting with local testing, so think debugging and unit testing as you develop your model, then moving up to batch testing, which is what we just walked through. So you're running your tests remotely on historical data, and then finally real-time testing. So this is running live on production data, kind of that final go, no-go step.
Makes sense. And so there are definitely like key components, right, that allow us to kind of do this across these different types of tests. Can you dive into that a little bit?
Yeah, exactly. So to do this in a systematic way, we think you need just a few foundational pieces, really. So in our experience, these are having your run history saved and accessible so you can view and replay runs like we did. And then having a set of named groups of inputs for those repeated tests. So you're all working from the same input data, and then a way to cut releases easily and collaborate on the same app versions across your team.
Yep. Yeah, and even sharing right across your team. So that
Yep.
makes sense. I think tech people, that especially the audience we have here today, probably is pretty familiar with like local testing, debugging, right, and doing all that type of work. But let's like kind of shift gears and talk a little bit more deeply about like the batch testing and real-time testing. I think that's like really where you start to get into the compute management. You know, we had somebody actually working on cluster management when we were at Lockheed. Now that's a whole different ball game because we weren't able to use like cloud compute and things like that. But I think it'd be really interesting to kind of dive into that batch testing a little bit more.
Yeah, for sure. So batch testing is a label that we give to describing a bucket of several types of tests. So you have your batch experiment, which is what we run. That's the kind of really quick comparing one or more models, and you really focus on the output there. So doing that kind of exploratory walkthrough versus acceptance testing, where we're focused more on, is the model passing a given test that we have set? So we're looking at some defined metric or threshold and asking, is it good or bad? And then scenario testing, we're focusing on, does the model perform well against different inputs? Really focusing on the variability here of those inputs, and then benchmarking. So that's typically looking at updates to a solver or maybe solving paradigm, and likely looking at more like performance metrics, solution quality over time type things.
Got it. Acceptance testing sounds a lot like, what we use with like GitHub Actions and like other CI tools, but for algorithm development. So maybe let's start there.
Yeah, so that's exactly how we're thinking about it. It's kind of how to get everyone on the same page as to what good is. So it's a flavor that looks at exactly two models, typically current production and release candidate, and gives you that kind of like green, yellow, red light. Are these metrics passing or failing? And really nice high level basis to have a decision conversation around.
Got it. And then you could dive into like those metrics that we were looking at before and kind of understand the trades.
Yep. Exactly.
Yeah, no, that makes sense. And so like, so we obviously like, this is like a really quick like view against like a standard set of inputs. Like realistically speaking, like we're a startup, like what if we're scaling the operation? What if we need to plan for like 10x volume? How do we think about that?
Yep.
That sounds
yeah. So this aligns. Yep. Yeah, exactly. More with scenario testing, I would say. Sometimes it's called stress testing for that reason, because you're really looking at like how much can we handle. And typically here you're working with one model and many inputs. So you're looking at the impact of variability on your results, and it's super helpful for answering like planning questions like how many vehicles should you include in your fleet over time, and how do you set up operations in a new city, things like that.
Yep. Yeah, that makes sense, right? And like it's more like how does your production model like actually scale, right? What about like transitioning from maybe like there like the solver ecosystem? There's a lot of different types of solvers out there, right? Even different within the same domain, right? Like mixed integer programming solver, you could have like 3 or 4 different ones. How do you look at like transitioning from maybe one of those solvers to another? And that's basically something that we're really focused on here at Nextmv too, right? Giving you access to a lot of different solver types.
Yeah, exactly. And that I would say falls into the bucket of benchmarking. So that's where you're really looking at these larger scale tests, focus on when you make that change in the solver, how does performance change? How do your solver times change? And so you're really looking at the solver options in particular, and how that model is constructed. So these tend to be larger scale, longer running, definitely important to be running these remotely kind of tests.
Yep, makes sense. So once we're happy with all of those,
Yep.
we're still basically just comparing plan to plan, right? Like this isn't actually hitting our real world operation at any point, right? Or affecting our drivers or affecting like our retail workers. So how do you start rolling these out to real world ops?
Yeah, so the first thing you might want to do is just observe a new model kind of in shadow mode for a little while, maybe for a single region or across your whole stack, and keep doing those comparisons. So it lets you run it on actual production data, but it's not influencing decisions. It's just running kind of in the shadows. And then the second option, and what we've worked with some users to do, is A/B testing. And in the optimization world, switchback testing is how we achieve that. It accounts for the network effects that are inherent in differing geographies and time. So it lets you do those tests on live production data and get to a safer rollout.
Makes sense. And I would actually specifically call out, we've heard a lot about like the, Instacarts and DoorDashes of the world, right? They have blog posts around switchback testing. And,
Yep.
specifically like a lot of people in our domain kind of like look at those posts and say like, I really want to be able to do that. We actually built out switchback testing specifically like at Grubhub for like our own use. So I think this is a key area that we're trying to enable on the testing side. I think we actually had a question, around kind of like, is it like easy to like add basically like some, compare against like a real world like baseline. And that is something that we're working towards. I think like one of the things here is we're standardizing output for comparing plan to plan so that eventually you can also compare plan to actual. So I think like that's a really helpful test, right? When you're thinking about this. Oftentimes, I think the production model, right, is close to actual. Obviously, there is some differentiation there because a plan is never as good as kind of the reality in some ways. But let's maybe you can walk us through some of the key takeaways here as we kind of wrap up, and then we can switch over to some questions.
Yeah, definitely. No, so I hope we've at least convinced you that testing is key to having confidence. I know it makes us feel a lot better that we can test our models and changes to our solver and all those things in a systematic way. We think it's helpful to add structure to the testing universe and help give you a pathway to getting to that confidence and to shipping things with tests. So you don't have to ship models to production without tests. And giving you some of that collaborative tooling around testing as well. So you have those standard input sets, you have a standard way of viewing results. We think is really helpful, and something we're working on at Nextmv. Cool. I think we have a couple of minutes at least for some Q&A. I can grab a quick question here. This one's for you, I think, Carolyn. How is scenario testing different from simulation?
Yeah, it's a super interesting question. I think as we've kind of built Nextmv, we kind of started with like wanting to provide like online like simulation capability, and then we quickly realized that a lot of people like aren't necessarily familiar with what we meant by that, right? So when I was at Lockheed, we were working a lot with like agent-based simulation. That is almost like SimCity, right? For your real city is like kind of the way I like to describe it. It's like actually almost like seeing a movie play out, right? Like it's obviously faster than real time, but you're managing basically like behavioral distribution. So you're saying like there's a model, there's a die roll, right, for whether a driver is going to accept an order or not, and you kind of see how that plays out over time. Really, like scenario testing is more around like, okay, let's test a range of inputs against the same decision algorithm and then compare the plan output. So it's a little bit like simpler version of what kind of a lot of people refer to as simulation. I think that word kind of gets like overloaded, and even when we're talking to users, right, a lot of users consider scenario, like when they talk about sim, they're actually saying like what we're describing as scenario testing here.
Yeah, no, exactly. Yeah, and in my world of disease modeling and like outbreak management, those simulations are literally, we simulate individuals interacting and transmitting, but sometimes you just don't have time. to run that large scale of a process. So scenario testing is a really helpful tool there.
Yeah, for sure. For sure. All right. I think we already had the question about, kind of comparing to actuals and simulation. Looks like we also had one come in around like, do we need to run through every test every time? Maybe Tiff, you can feel that one.
Yeah, sure. I would say just quickly, no is the answer there, but it's a bit of a choose your own adventure. So you'll probably want to do a little bit of local testing, some batch testing, and maybe some real-time testing, but it depends on your operation. So if you are kind of running these models and planning daily or weekly, you probably don't need switchback testing, but you have a real-time delivery business, that's a super helpful tool. So it depends.
Yeah. Awesome. I think like the key here is like we're trying to give you those pieces so you don't have to think too much about the pieces. You just access them when you need them.
Yep, exactly.
Yeah, sure. Awesome.
Cool.
Well, I think that's all the questions we had for now and all the time we have. So maybe Tiff, if you can wrap us up here.
Yeah, for sure. So here's where you can find us. I would say we're always looking to put together product feedback groups. So please reach out if you have thoughts and would like to be part of this. There might even be some fancy swag in it. And we will be sure to share the recording with you after the talk. And just thank you again, everyone, for joining us. Until next time.